Hello, we are from the Team 6 from the group 33 and we are going to talk about dangerous residues. My name is Agustin.
My name is Darian.
My name is Ricardo.
My name is Marisol.
And this is our project.
According to the General Law for the Prevention and Integral Management of Waste, a dangerous residue or hazardous waste is a material or product whose owner discards and is in solid or semi-solid state, liquid or gas contained in containers or tanks, and can be valued or require disposing to treatment or final disposition, and also contains at least one of the CRETBI characteristics: corrosive, reactive, explosive, toxic, flammable, or biological infectious. It's considered dangerous the waste itself and also the containers that have contained the hazardous waste. A waste should have this consideration when it meets one or more of the following characteristics, as set out in Annex 3 to Soils in Spain: explosive, oxidizing, easily flammable, flammable, irritant, harmful, toxic, carcinogenic, corrosive, infectious, toxic to reproduction, mutagenic, residues that emit toxic or highly toxic gas when coming into contact with water or air or with an acid, sensitizing, ecotoxic, and waste susceptible after disposal to give rise to another substance by any means. Until a few decades ago, waste, now classified as hazardous, was part of the industrial, hospital, and even home waste. These were deposited in unauthorized places such as dumpers, riverbanks, or were simply poured into the water or disposed of in municipal landfills together with household solid waste. There are many known events that, as a result of these bad practices, have caused damage to the population and human health, such as the accumulation of lead salts in northern Chile and nearby sectors, have caused neurological problems, leukemia, and teratogenic effects in the adult population to the child population. Environmental awareness led developing countries and developed countries to legislate on the subject matter and to legislate on its classification, storage, and final disposal. As a result, environmental engineering has played a leading role in shaping hazardous waste management plans, and on the other hand, the authority has had to standardize these activities. Because of these legal regulations that the state, in its role guaranteeing the preservation of public health and the environment, has developed environmental laws in this regard. Hazardous waste generators, in turn, have been forced to classify their waste, sorting, and contracting services for processing and final disposal. The dangers to the population and the environment come from the intrinsic hazardous properties that pose health risks.
Now that we understood what is a dangerous residue and what can cause, we need to establish a plan to control the production of this substance, since, as we mentioned, it can cause serious problems to the environment and, therefore, to our health. The best solution to solve this waste problem is avoiding it, and to achieve this, the first thing to do is to encourage the non-generation of this waste in the source of its production. The solution we're proposing is known as minimization, and it's referred as the set of dynamic measures oriented to decrease the productions of, in this case, dangerous waste, decreasing the management cost by the business and protecting the environment. Minimization not only avoids the contamination problem, it also reduces the cost that implicates to clean it, avoiding at the same time the legal responsibility of the company. A study made by the World Bank about minimization cases showed that in half of them the investment was recovered in less than a year, and in the others in less than 4 years. Of 115 cases of minimization, just in one the company could not recover the investment made. Spain is one of the countries that regulates a waste minimization plan. This plan is a legal demand for the dangerous waste producers that derives from the Royal Decree 952/1997. This norm states that in a 4-year term from the entry into force of this royal decree, and later with the same periodicity, the producers of toxic and dangerous waste must elaborate and refer to the corresponding autonomous community a minimization study of said waste per unit produced, engaging with reducing the production of toxic and dangerous waste in the extent possible.
I'm Daniela Ramirez from Team 6 and my part is Experimental Result.
Experimental result. We evaluate the performance of the proposed method and compare it with that of the betweenness, out-degree, and random method. Clearly, the performance of the method of solving the contamination minimization problem can be evaluated in terms of contamination degree C. We use the value of C that is estimated by the bone percolation method with m equals to 10,000. Figures 3 and 4 show the contamination degree C of the resulting network as the function of the number key of links plugged for the block network, where the circles, triangles, diamonds, and squares indicate the results for the proposed betweenness, out-degree, and random method, respectively. In Figure 4, the dashed line indicates the contamination degree of the network obtained by the proposed method of key equals to 100. From Figure 3 and 4, we first see that the proposed method outperformed the betweenness, out-degree, and random method for the block network. By taking into account the definition of contamination degree, we can mention from Figure 3 that the proposed method decreased the expected number of nodes contaminated, from about 980 nodes to about 580 nodes by blocking appropriate 100 links for the block network. Here note that blocking 100 links means blocking about 0.13% of the links in the block network. Thus, we found from Figure 3 that by appropriately blocking about 0.30% of the links in the block network is proposed by betweenness method decreased contamination degree by about 41% and 30% respectively. Hence, we can deduce that the proposed method was effective and also outperformance the betweenness method of over 10% at key equals to 100 for the block network. Moreover, we found from Figure 4 that blocking 100 links by using the proposed method was the same as blocking over 10,000 links by using the out-degree and random method from the block network in effect. Namely, we deduce that the proposed method was 100 times more effective than the one of the out-degree and random methods at key equals to 100 for the block network. Figures 5 and 6 displays the contamination degree C of the resulting network as the function of number k of links plugged for the Wikipedia network. In Figure 6, the dashed line indicates the contamination degree of the network, obtained by the proposed method of key equals to 3000. We also see from Figure 5 and 6 that the proposed method outperformed the betweenness, out-degree, and random method for the Wikipedia network. In particular, we observe from Figure 5 that as a value of key increased, the performance difference between the proposed and betweenness method gradually increased. Note here that the blocking 3000 links mean blocking about 0.12% of the links in the Wikipedia network. These results imply that the proposed method works effectively as expected. That significant outperformance, that is the betweenness, out-degree, and random method.
Now that we find a way to minimize the use of hazardous waste, we need to start applying it. By recycling these materials, we can help our ecosystem stay healthy just like people. Thanks to recycling and minimizing the use of hazardous waste, several of our country's ecosystems will benefit from no longer being overexploited for the creation of them. Natural resources will no longer be used in an exaggerated amount. Energy and minerals will be seized. Because the creation of hazardous materials is the exclusive of several industries, albeit in more part of the heavy chemical industry, industries such as forestry or agribusiness will be forced to reduce their production by minimizing consumption of products. In addition to the preservation of ecosystems and natural products, the transport of hazardous products would benefit, as would the people who are transported in their day-to-day life. It is very common for people to be afraid of driving to the side or behind a transport carrying some dangerous product, because, as we have already said, most of these are flammable, corrosive, reactive, explosive, toxic, and if in any case an accident car will happen, there is a possibility that some of the products react and turn the accident into a much bigger problem that will cost the lives of many people. In addition to minimizing the use of hazardous materials, so can waste from them be used to create new products without the need to exploit more natural resources. Fuels can be used for the creation of energy or electricity. Also, the mercury of some useless thermometers can be distilled for reuse, as well as lead that can be used for the creation of various batteries. Now that we know many benefits that will bring us to minimize the use of hazardous materials, it is good that we begin to stop relying on the use and be able to discover new activities that, although we see them very innocent, are very harmful for our ecosystem.
To sum up, and with the information stated above, we can say that the improper disposal of dangerous residues can pollute the environment, like when industries throw their residues in lakes or grounds and affect the habitat of a lot of species. Also, they can pose a threat to human health. There are also residues of this type that are called household hazardous waste, that are the residues that we produce commonly on houses, that have the potential to cause physical injury to sanitation workers. Contaminated septic tanks or wastewater treatment systems if poured down drains or toilets, and even then cause damage to children or pets if they are left in the house. That is why it is very important to manage safely these dangerous residues. With the solution we proposed, minimization, we can reduce the origin of these residues or recycle the subproducts that need a treatment or final elimination. We can also help to reduce these residues with small things, such as read the labels of the products, like chlorine, that needs specific places to be deposited. Buy natural soaps, reduce softener in clothes, and instead use baking soda. Avoid air fresheners, use rechargeable batteries and get rid of them by putting them in containers. With our help, we can reduce the damage that the environment receives every day. We also need to conscientize future generations to protect their planet. Also demand industries to stop throwing their residues in wrong places.